So what Ken described, and hopefully it was evident to all of you guys on this webinar, is really an incredible vision. It's a tremendous, it's just a tremendous innovation and very, very ambitious and many, many moving pieces to it. So really my job as really the chief architect or acting CTO is really, if you like, a town planner. I need to be able to, you know, if you take this analogy, be able to design the roadways, the different zip codes, different neighborhoods are connected to each other in a way that allows us to continue to build up the town, but also to be able to discreetly work on any one neighborhood without impacting the other ones. As just as a metaphor. But really, it's very much this idea of building modularized software using microservices and exposing that technology, exposing the functions with application programming interfaces, and then within the deployment phase, deploying and using containers and Kubernetes and technologies like this to manage the deployment. So that's really what we have built and continue to build. I'm not going to go through this conceptual architecture in detail. I think all I really want you to take away from this slide is that we have many moving pieces. If you like, those boxes are the zip codes, and the line items within them are the neighborhoods, right? And of course, there's many, if you like, many houses and stores and things within those neighborhoods. So that's really the world that we live in. And our challenge is to make sure that, well, first and foremost, that everything is safe, secure, performing, and reliable. That's number one, sacrosanct, right, above everything else. And that's what Ken obviously always, kind of brings to the forefront. Because we are a HIPAA compliant provider. We are dealing with patient data. That is by far the most important thing. But that aside, really is about how do we make this innovation happen in a way where we have a very large and distributed decentralized engineering team. I think last count, somewhere over 70 engineers around the world. How do we make this work such that we're efficient, we can work autonomously and independently, yet within essentially one signature pattern, right? Because that's the challenge, right? We cannot just do our own thing and expect to have this very convoluted, complex, and featureful technology all work. So that's really what we're doing. Again, I'm happy maybe if there are specific questions later on to get into any specific details. One thing I would like to mention is, as you can see on the right-hand side of the screen, is we do have a lot of integrations as well for many different purposes and with many different partners, including Hedera. And this goes back to my point earlier about using APIs and how important that is. As much as we all love blockchain, and of course we're here to talk about, how we're using Hedera and real-time DLT services, really the secret sauce for building this kind of a solution is to be interoperable. It's to, by design, be open, have open technologies that can be, that can interoperate. And we've really tried to do that, and I have a slide a little bit later on that basically talks through that. Okay, moving on. So this is, again, I'm not going to go through all the details of our architecture, but it is a very modern architecture. We do use cloud services where we have Azure and AWS and some redundancy between the two. We do use as much as we think it makes sense some Cloud OS services. Our philosophy generally is to build technology that is as decoupled from infrastructure and components as possible. In some cases, and those of you guys who are technology architects will notice, the business demands and budget demands and constraints, just basic kind of constraints theory limits how kind of ideological it can be. However, we have a roadmap, like I mentioned, we have a signature pattern. So we know as time goes on how to evolve, but nonetheless, we're also realistic in what it takes to actually get things done in the short term, because none of us has infinite time. So that's really kind of what we have. And again, I'm not going to get into all of the kind of components, just to say that it's really built kind of from the ground up to be modularized as much as possible and exposed using the APIs and deployed with containers. Okay, moving on. So this may be the areas that are really interesting to most of you folks, with a Hedera background or some Hedera interests. So we are big fans of Hedera, have been for a number of years. My company Acoer has been a Hedera partner for, I think, since the beginning, really. Even in the days when I was at the CDC and Ken and I had just started, our kind of friendship and working together, and way back in that time, we were interested in what Swirls was doing and where what seemed like amazing technology could go. So the advent of Hedera a couple of years ago as a public DLT was really exciting, because it, again, ultimately, this is what I believe, it's what Ken believes, that in order for us to innovate in healthcare, we need to be thinking real time. We need to be thinking about technologies that are really consumer oriented. Hence the great job that we have done, and the vision Ken has with the mobile apps, this real-time services, this lowering of costs, but providing a usable experience. We very much believe in this, and I think that was one of the reasons that Ken and I got together early this year to figure out how we could take our our technical experience and expertise and marry it with what Ken already had in place, and really try and grow this vision into a reality. So all to say, really this idea of transaction authenticity is one that we're really kind of keen on. And what we're doing, what I'm demonstrating here, again, is at a glance, it's not all of the details. It's this idea that, we are able to take medical endpoints, and I give you a specific example. When Ken was going through the demo on the app, the development app that he was showing, clicking through the different questions of the CDC protocol for COVID, at the end, he came up with what we call a medical endpoint. The endpoint was you're symptomatic, and it was a dummy placeholder for a message, but nonetheless, the actual medical endpoint was that, he was symptomatic based on the results of the questions. It was providing an R algorithm. So that particular symptomatic diagnosis, there is an encrypted reference of that on Hedera. We created that in real time. And this flow essentially shows how we've done it. I'm not going to go through all of the details, but essentially it shows that the process, as Ken demonstrated in real time, to go through the questionnaire, the resultant medical endpoint, the diagnosis, if you like, and then what we do thereafter to take that specific transaction and record that transaction on Hedera using our Hashlog data stamping service. So, and then later on, if there's a regulator or if there's public health reporting or any other reason for us to go back and essentially try and verify the authenticity of that particular transaction or anything like it, we're able to do so because we can show that the chain of custody of the transaction is not broken, that there's an immutable transaction on Hedera that proves that with the right and specific data stamps. So again, not to get too detailed about it, but this is really core to the way we think about this idea that Ken had described, which is real-time transactions and really proactively proving, having a proofing service that shows the critical elements of our application and our technology actually working in a way where the data and the transaction can be relied on. And really, in my parlance, we're imputing computational trust. That's the whole reason why we're trying to do this. So you don't have to trust Ken or myself because we're good people, or because we're using some giant intermediary as a trust mechanism. You can trust the cryptography and Hedera's infrastructure. All right, moving on. So Ken also mentioned that we generate a unique ID. We call it the National Health ID. Essentially what this is an ID that we use Hedera Consensus Service for. We have an algorithm, and for obvious reasons, I have not disclosed the specifics of the algorithm, but that algorithm, whenever a user is created, the algorithm essentially calls HCS or runs the algorithm, and we create this number, this unique number using HCS, right? And then that number, though with no reference back to the patient, of course, is available for interrogation on the public DLT. And this is really to prove that the number is unique, because we have a big vision, and Ken intimated about this, to really do patient matching, to really take this concept of a unique ID and actually make it unique across different data sources. As most of you guys do know, perhaps the single biggest issue in healthcare is siloed data. Jim Nasr is on like 17 different health systems, and possibly 16, 17, 18 different variations, even within the same system, of my record, different spellings, the different IDs and things like this. And ultimately, this is something that can be resolved, though obviously not just by technology. There's policy, and there's many other things that are involved. But really, mass adoption is the way you could accelerate this kind of a concept for policy and legal provisions to catch up. All to say, this idea of taking that national health ID and really associating it across different siloed data sources that really are, again, just reflecting my record, but are not necessarily, you couldn't uniquely identify me directly from. So moving on, this is, again, we're doing a lot of really, what I would say, kind of on the edge design and pretty interesting machine learning and entity resolution and other experiments. What it takes for us to take this national health ID and really do cross-linking and matching. So and again, this is illustrative of the work we're doing, but ultimately on the left-hand side of this picture are the many different data sources with which we are interacting with or could potentially interact with, including network of networks, feeds, and things like this. So just thinking ahead, on the right-hand side is really our campus and our technologies and our stack, and how we're essentially using our data lake and our entity resolution technology and our own patient data records, and really trying to, in as interoperable way as possible and in as kind of real-time way as possible, do this kind of a cross-linking, and then ultimately impute this national health ID or assert it and insert it across different data sources. As they say, watch this space, that there's a lot happening here. We're excited by it, but it's very ambitious, and it certainly is one of those things where we think if we can do this and do it well, that this has a real material impact across the industry. Moving on, I did mention a little bit earlier that we have a real commitment to open standards. We actively really think about this. We push our development team to build code in this way. We really just in many ways insist on even at the lowest level of nomenclature and naming convention, and how we do our Swaggerized API documentation to be very, very consistent and very, very kind of adamant on doing it in this way. And reason being is that we're building a very large system. If we're unable to isolate functions, unable to isolate fault, unable to build in parallel, we will never reach our goal. So that's really that's part of it. On the right-hand side of this picture, you see the predominant technologies, healthcare technologies and standards that we're working with. And again, our direction is largely FHIR, which is a fast healthcare interoperability resources standard, which is really a deviation or variation of RESTful API. So very much proven, has been around for 10 years, and very, very importantly, is now adopted by the Cures Act, the 21st Century Cures Act, which is law as of January 1st, 2021. That really basically stipulates that EHRs, EMRs, electronic health record systems, they need to support this FHIR as a way for allowing standardized or standard protocol-based patient data access. It's a very, very important concept. It's one that I am very hopeful is going to propel all of us as individuals and patients into a much more modern and freer way of getting to our patient information, and also, frankly, allow our agents, entities such as Safe Health, to be able to help us get to that data and then possibly cross-pollinate or cross-reference our data to help us make better decisions, cheaper decisions in a more comprehensive way. Ken also mentioned the Apple Toolkit, Acoer project, or we're members of those and leverage those. And again, our services are not just about, kind of diagnostics and kind of COVID or any one kind of just one or two particular areas. We're really trying to kind of at large build a system that they can deal with very large and a large number of low complexity health conditions. So therein, preventive healthcare and other kinds of interactions and exchanges is really important to us. Moving on. All right, so this is a little bit more technical. I'm not going to go through it in a whole lot of detail, but since this is a Hedera conversation, and I know most of you guys are familiar with our proofing or data stamping services, and you're possibly familiar with some other proofing services, including Hedera's own state services. This is just to show what we do, right? We have a serverless kind of architecture that we use, including a serverless database with Fauna, and then ultimately, what we're really trying to do is expose the functionality as APIs and really abstract out all of the backend infrastructure. So any one of us, whether it's our team at SAFE or whether it's other clients or independent developers, can use those APIs without having to worry about scaling, without having to worry about infrastructure, deployment of servers, none of that, right? Because all that really creates more of a distraction and complexity, and we really want you to get value from the service and not have to worry about all of the configuration and all of the scaling and all the other things that then we as engineers have already thought through. This next and last slide is really just a high-level flow of our data stamping service. Again, it's pretty technical, but really all we do is we're generating a JWT, a JSON web token, and then we're essentially passing it through the different layers of the infrastructure. And then ultimately, whether it's through our own proofing services with barcodes or other artifacts that we're working on, or whether it's through some other third-party proofing services, we're able to prove that transaction. And then certainly, as I mentioned earlier, we're using this already in production. I think as of today, I was just looking it up. I think we've had over, I want to say 2.7 million transactions and this on the Hedera mainnet. I was just projecting from yesterday, because yesterday was just over 2.6 million, and the rate of growth has been very, very significant. So, and then Ken mentioned this in his conversation as well. We've had well over 1 million transactions just from SAFE alone. So really we take this very seriously. We're doing this in production, and ultimately, like my belief, is, and I think Ken really believes in this as well, that it's time for us to use DLT for real, and not just yet another, private blockchain proof of concept with 3 nodes. I mean, I think we have proven that serves a purpose, but that doesn't necessarily serve many purposes, or doesn't necessarily provide transparency or this kind of scale that we're trying to get to. And then therein the opportunity to be able to marry the 2 concepts, perhaps using Hedera Consensus Service. Okay, I think that's all I have to cover on my end. Hopefully I did not bore you guys too much or run over time.